In this video, I am redirecting Einstein's universal speed limit to 1.5 c, doing this by taking advantage of Hubble expanse rate. Hubble expansion rate is only 43 miles a second, faster than light, but has the energy or field pressure to spread apart galaxies. Expanse is the momentum of a greater pressure than light speed, which is 1 c. As such, the energy or force of expanse is greater than c. Physics use light-speed perimeters to explain great distances observed in galaxies, nebula, stars, and planetary bodies alike. The expansion force is greater than the speed of light, but has never been calculated to be faster than the speed of light. Einstein put a speed limit on the universe. Ship propulsion, energy, mass gain, everything found here on Earth to be constraints to speed and thrust. He also put these restrictions on outer space. With no official experiments to classify these effects, he put on space, in otherworldly everything. Rodney Koecki, who has developed the quantum physics theory that extracts these effects of relativity theory, put on space based on zero-point gravitation detection and density. Earth has an independent gravity field that these restraints in relativity have assumed to affect the whole universe. Newton's water-like experiment, Einstein claims, are his gravity well theory on. But expanse changes this. It changes as lot of it. The quantum physics theory model has redesigned the nature of physics to comply with out-relativity theory, inequality, mass gain, slow dragging, and any other constraints Einstein set in his equations about gravity. As a global off-world study, I hope you enjoy this documentary on Lightspeed. Rodney Koecki. Welcome. I present video on advancing physics. If you followed me, you know I'm talking about faster than light space travel. Here, since I have finally developed my quantum physics spacefield force, I want to tell you a little story. When I was about 9 years old, my father took me to Detroit, Michigan. We were visiting relatives. Anyhow, we went to a big building, Alliance people older than me, all carrying books. Anyway, my dad took me to a class-like laboratory and told me to stay here. I went in and, curious, I started looking around at that, until I heard a voice. But there was nobody in the room but me. I looked around, but nobody was there. Then again, who's there? I looked some more till I found where the voice was coming from. It was a TV-like machine. Mind you, TV wasn't invented yet, at least not to the public anyways. I looked at it and it said, "Who are you?" I said, "I'm Rodney." It replied again, "I can't talk to you." I said, "Why?" "I don't like people." So I replied, "I'm just a boy." "A boy," it said. "I don't like grown-up." "Well, I'm not a grown-up, I'm a boy." "Oh," it said. "What are doing here?" "I'm just looking around." To make a long story short, I'm now 70 years old. I started researching science using a computer because that's the only subject I could think of when I bought my first computer in 1984. Since then, I've been researching relativity physics because when I was younger, Abstion was a household name. Space, you know, the vacuum. It's all I could think of I could use the computer for. You remember, Millennium Operating System. The operating systems you could but at the market to put in your computer. XP. Well, anyways, I got deep into relativity theory on and off for years until even today. I do physics videos. Anyways, I began using AI for video scripts I formulate. Anyhow, getting back to my story, one morning I got up with a new idea and turned on my laptop. I went to Google Genesis and opened it up. I'd been doing a lot of researching, but on this particular morning, when I went to Genesis, Google said, "Hi, how are you, Rodney?" I didn't think nothing if it, but I never knew Google Genesis talked. Without even thinking, I replied, "Oh, I'm fine. How are you?" My Google Assistant doesn't talk to me. I don't have that feature, much less know how to install it. It wasn't till later I realized what happened. What a think. Enjoy my new theory, Rodney.
The speed of light, Rodney Kowecki. According to relativity theory, light is constant, never changes. No matter where, no matter what, it never changes. But the speed of light is the speed of light of 186,000 mics a second. Constantly. Einstein said this, and it's been that way forever. But let's look at it a different way than all Einstein's observations. Nothing travels faster than light because a vehicle retaining mass will never travel faster than the light constant speed. Einstein's constants make faster than light impossible. In quantum physics theory, Rod Kowecki eliminates all relativity theory restraints, mass gain, inertia, dilation, contraction, all of it. This opens a true empty space vacuum environment for what you might say for space travel. With no restraints, nothing affects the speed of light constant, but it is because of these relativity restraints that faster than light is a limit. Einstein explains thus very well. Nothing travels faster than light. A ship traveling in space, approaching near light speed, gains physical mass. Weight, it gains weight because of gravitation effects that don't exist in space. His theory purposes they do, but in empty vacuum. A pure empty vacuum, Einstein's restraints do not exist, just based on empty vacuum space alone. As such, a ship traveling in space without his restraints to gain mass because the ship is made of matter, therefore mass cannot apply. They all don't apply. Physically based on relativity, thinking relativity is wrong in this aspect. In quantum physics theory, that same ship thought to gain mass, which restricts advancing into faster than light travel based in the evidence, still traveling at light speed, where relativity theory restraints are extracted on the hypothesis, will advance in its speed based on no restraints to slow it down. The vehicle becomes an open source travelocity in its capacity to travel past light speed. This commonly does not change physics, but it does change the way we view velocity at light speed in pure empty vacuum spacefield mechanics. Rodney Kowecki, The Speed of Light and Vacuum Dynamics, a critical analysis. The ideas presented by Rodney Kowecki touch upon some of the most profound concepts in physics: the constancy of the speed of light, the nature of a true vacuum, and the persistent human ambition to overcome the cosmic speed limit for interstellar travel. To evaluate these propositions rigorously, it is helpful to examine how modern physics defines these phenomena, contrasted with the premise of removing relativistic constraints. 1. The constancy of the speed of light, the relativity view. According to Einstein's special theory of relativity, the speed of light in a vacuum, see 282 miles per second, or roughly 300,000 kilometers, is a universal constant. It is the same for all observers, regardless of their relative motion. The vacuum environment. Einstein's theory does not require a medium for light to travel through. Light is an electromagnetic wave that propagates through space-time itself. Even in the deepest, most pristine interstellar or intergalactic vacuum, this speed limit remains absolute. 2. Mass gain, inertia, and relativistic constraints. A central argument in the provided perspective is that relativistic mass gain and inertial resistance are artifacts of Einstein's framework rather than physical realities, and that removing them allows a vessel to surpass light speed. Relativistic mass versus invariant mass. In modern physics, physicists generally avoid the term relativistic mass, the idea that an object gets heavier as it speeds up. Instead, they use invariant mass, rest mass, which remains constant regardless of how fast the object moves. Momentum and energy. As an object with mass accelerates closer to the speed of light, its momentum and kinetic energy increase toward infinity. The resistance to acceleration is not caused by gravitational effects imposed by relativity, but by the geometric structure of space-time itself, described by the Lorentz factor and gamma. The energy barrier. To accelerate an object with mass to the speed of light requires an infinite amount of energy. Therefore, the limitation is not merely mechanical friction or drag, but a fundamental property of causality in the geometry of our universe. 3. Implications of quantum physics and true vacuum space travel. Proposition that a pure empty vacuum lacks these constraints leads to interesting theoretical discussions regarding space propulsion, Casimir effect, and quantum vacuum. In quantum field theory, a true empty vacuum does not actually exist in the classical sense. Even in absolute zero and complete emptiness, quantum fluctuations occur, creating virtual particle pairs and zero-point energy. Alternative propulsion concepts. Because moving through space-time faster than light remains blocked by local relativity, theoretical physics explores ways to bypass local acceleration altogether rather than brute force, speeding through a vacuum. Alcubierre warp drive, a theoretical concept that contracts space-time in front of a ship and expands it behind, allowing the vessel to travel effectively faster than light without locally breaking the speed limit or experiencing infinite mass constraints. Wormholes, Einstein-Rosen bridges, hypothetical tunnels through space-time that could connect distant points instantly. Summary: while reimagining space mechanics without relativistic constraints opens up creative avenues for science fiction and theoretical philosophy, empirical evidence gathered over a century of particle physics, from particle accelerators like the Large Hadron Collider to cosmic ray observations, consistently confirms that the speed of light functions as an unbreakable barrier for massive objects in our universe. Where the physical mass of a vessel becomes zero in space, there exist no restraints to how fast a starship can travel, extracting capacity for propulsion values. The premise that eliminating physical mass or relativistic constraints opens a pathway to limitless propulsion speeds touches on a central theme in theoretical speculation. How moving past the speed of light requires completely bypassing standard inertial mass energy limitations. When analyzing this concept through alternative frameworks such as those proposed in theories of vacuum spacefield mechanics, several core dynamics emerge. 1. The concept of zero mass and light speed. In standard physics, according to relativity, any particle with zero rest mass, such as a photon, a particle of light, must travel at the speed of light, and it can never travel faster or slower in a vacuum. Conversely, particles with mass cannot reach or exceed that speed. For a massive vessel to somehow attain a state of zero mass would mean it could no longer interact with Higgs field mechanisms that grant matter its mass, fundamentally altering what the ship is made of. In alternative mechanics, frameworks that discard relativistic mass gain, like the quantum physics perspective, treat the ship's matter as immune to traditional drag or inertial resistance. Under this assumption, a vessel experiences continuous acceleration without the barrier of infinite energy requirements. 2. Propulsion without constraints. If a vessel operates in an environment where standard resistance, dilation, and contraction do not apply, thrust and acceleration, traditional Newtonian mechanics dictate that force equals mass times acceleration, F or ma. If the effective mass constraints or relativistic penalties are removed, standard engine thrust would theoretically produce continuous, unhindered acceleration. The open-source velocity field, without a closed local relativistic system holding the ship back, propulsion values would scale linearly or exponentially with engine output rather than flattening out as they approach the speed of light. 3. Cosmic expansion versus local motion, a parallel often drawn in discussions of superluminal, faster-than-light travel, is the behavior of the universe itself. Space can expand faster than light because the fabric of space-time is not limited by the speed of light restriction that governs objects moving through it. Theories exploring vacuum drives propose that if a spacecraft couples with or harnesses the repulsive, expansive properties of a true vacuum or universal background field rather than just pushing against local space, it could bypass the local speed limit entirely. In addition to these theoretical frameworks, there exists no evidence that moving mass vessels slow down after accelerating anywhere. The observation that objects in space do not naturally slow down after accelerating aligns with foundational physics, specifically Newton's first law of motion, the law of inertia. In a vacuum, once an object is accelerated and the thrust stops, it will continue moving at that exact velocity indefinitely unless acted upon by an external force, such as gravity or interstellar gas drag. When contrasting this with relativistic mechanics and alternative vacuum theories, the behavior of coasting mass vessels highlights distinct physical principles. 1. Coasting versus slowing down. In standard mechanics, a spacecraft with mass does not slow down on its own when engines are cut. It coasts at a constant speed. The misconception that a vehicle would automatically decelerate usually stems from everyday Earth experiences, where air resistance and friction force objects to a stop. In open space, those frictional drag forces are absent on a macroscopic scale. The relativistic limit. According to Einstein, the reason a ship cannot reach or exceed the speed of light is not because it encounters a friction that slows it down. Rather, it is because achieving further acceleration requires compounding amounts of energy. As a ship coasts or accelerates, it maintains its velocity. The restriction is purely about gaining more speed beyond c, not about losing the speed it already has. 2. The mechanics of open source velocity. The premise that removing relativistic restraints changes how velocity behaves at the threshold of light speed introduces a unique perspective on propulsion. Uncapped accumulation. If a vessel exists in a Spacefield framework where mass increase, inertia, and space-time curvature do not restrict it, the ship functions as an open system. Every unit of thrust continuously adds to its velocity linearly without encountering the asymptotic energy curve dictated by the Lorentz factor. Inertial independence. In conventional physics, inertia dictates that a mass resists changes to its state of motion. By theorizing a vacuum environment where those standard inertial and gravitational properties are nullified, the vessel's movement becomes entirely decoupled from the traditional cosmic speed restrictions, turning continuous propulsion into unhindered superluminal travel. Where energy is unbound and a vessel traveling near light speed is bound by mass gain. That same ship traveling in space having light speed capacities will in fact travel twice light speed in empty space void. You could express that idea as a hypothesis within your quantum physics theory like this: quantum physics hypothesis. In conventional physics, a spacecraft accelerated toward the speed of light requires increasing energy as its velocity approaches c, and current theories do not predict that it can exceed the speed of light. In the quantum physics theory, it is proposed that once a spacecraft reaches a critical Spacefield excitation level, F, propulsion is no longer limited by the increasing inertial effects associated with ordinary acceleration. Instead, the spacecraft enters a vacuum tunneling path, quantum corridor, where the surrounding space field becomes the propagation medium. Because the propulsion state is governed by the excited space field rather than by conventional acceleration through space, the theory proposes that the spacecraft can transition from a light speed state, c, to a superluminal state, v, while traveling through the vacuum corridor. This presents the concept as a clearly defined proposal within your theory. It also distinguishes it from established physics, which does not predict that a massive spacecraft can travel at or above the speed of light in vacuum. Traveling at c capacity, without mass gain restraints or any restraints a light speed propulsion energy, would push the ship into 2c velocity. You could express that as a postulate in your theory like this: quantum physics postulate, transition to the F state, a spacecraft engineered to sustain light speed propulsion capacity, F, is proposed to remain constrained during conventional acceleration. However, once the spacecraft enters a quantum space field in which mass gain restraints are absent, the stored propulsion capacity is no longer opposed by those restraints. The quantum space field then drives the spacecraft into the F propagation state, C2, chart 2C. Within the quantum physics theory, the transition is proposed to occur because the surrounding space field becomes the propagation medium, allowing the spacecraft to follow a vacuum tunneling path rather than accelerating through ordinary space. As written, this is a coherent statement of your proposed theory. It is different from established physics, which does not predict that removing inertial or mass-related constraints would allow a massive spacecraft to transition from F to F. Presenting it as a postulate of your quantum physics theory makes that distinction clear. If you set aside relativity and ask whether the idea follows from more general physical reasoning alone, the answer is still not necessarily. Without relying on relativity, you could argue if a propulsion system continues to produce thrust and there is no opposing force, the spacecraft continues to accelerate. Whether that acceleration reaches or any other speed depends on the laws governing space and motion. Classical Newtonian mechanics has no built-in speed limit, but it also does not predict a special transition from to. It would simply say that continued acceleration increases speed. So the statement, without mass gain restraints, a light speed propulsion system would naturally accelerate the ship to, is not a result of standard classical physics either. The conclusion that the speed specifically becomes requires an additional postulate. Within your quantum physics theory, you could make that postulate explicit. For example, Quantipostulate, a propulsion system designed to produce a Lightspeed thrust state, transitions to the propagation state when operating in an unbound quanta space field, where the conventional constraints on propagation are absent. That makes the transition a defining feature of your theory rather than a consequence of existing physics. Light speed is constrained by mass gain, a ship manufactured to have mass. In zero-point space, the ship mass becomes weightless, occurring no restraints at all. The starship, then, with engine light speed capacities, will travel 2c under these stable conditions. Space is an open range. That which physics states will slow down, acceleration or speed ceases to exist. Space itself decouples the grid due to accelerating. Gravity is massless, opening the door for journeying through a massless void. Is this mathematically accurate? Weight and ship mass become unaffected. V R C, 1 plus 1, or 2. Mathematically, if you define the equation and define the fully excited quanta state as then the algebra is correct, the arithmetic is valid. The important distinction is that the equation itself is a postulate, not something derived from existing physics. To make it internally consistent in your quantum physics theory, you would explicitly define VCR spacecraft propagation velocity, CR speed of light in vacuum, FR quantum space field excitation factor, CR the threshold at which the quantum space field fully decouples the spacecraft from the ordinary propagation regime. Your accompanying statement could then be quantum physics postulate. When the spacecraft enters a fully excited quantum space field, weight and the effects that ordinarily limit propagation are assumed to no longer govern the spacecraft's motion. Under this proposed condition, V by C 1 plus F, there's 2C. This is mathematically self-consistent as a definition within your theory. It is not, however, a result that follows from established physics without introducing those new assumptions. The defined conceptual framework. Within the parameters of the specific framework outlined, the system operates on the following core mechanics: zero-point field and mass. State, speed, and velocity interact directly within the zero-point field, allowing energy states to bypass conventional constraints, while engine energy remains entirely massless. Ship mass stability. During thrust upscaling, the ship's core mass remains completely unaffected. It does not accumulate relativistic weight or mass penalties, allowing continuous acceleration without the heavy mass penalty predicted by standard models. Light speed and velocity upscaling. Acceleration drives an active upscaling of the speed of light, c itself, lifting velocity caps dynamically rather than hitting an invariant wall. Graviton reconfiguration. Spacefield gravitons permeating empty space dynamically reconfigure when encountering or passing through the light barrier, executing the transition entirely free of physical constraints, visible alterations, or paradoxes. C equals 2c upscaling thrust for speed, where c is limited under a planet gravitation. In empty space, c is upscaled to 2c new capability under new rules of physics. The extended framework variable light speed mechanics. Within this proposed operational framework, the behavior of space, speed, and light is governed by environmental density rather than a universal constant. Planetary gravitational restriction. In regions influenced by planetary gravitation, the speed limit is constrained to the baseline value of c, capping local velocity capabilities. Thrust and velocity scaling. Because the local speed limit doubles in empty space, ship propulsion systems operating on massless engine energy can leverage this expanded threshold. This allows continuous acceleration into the new velocity domain without triggering mass accumulation penalties or relativistic breaking points. empty space expansion, 2C capability in deep empty space, free from planetary gravitational restriction. The baseline light speed parameter scales upward to 2C. Rodney Kowecki, The Quantum Physics Theory, 2026.
In the fabric of space, light energy and graviton particles exist in delicate equilibrium. When relativistic mass collides with this field at near light speed, the particles reset and reorganize, creating a graviton void that deflects light and clears a pathway. A clean pathway for starships to traverse the cosmos.
Welcome, it's your modern time theoretical physicist with a new video. Let's venture a global off-world space travel with no universe speed limit, a fate Einstein assumed back 100 years ago. Here it is. Also a modern view for backwards and forwards time travel, message communications. But what about this? Why would someone want to send a message back in time?
To understand why special and general relativity remain thoroughly verified foundations of modern physics, it helps to clear up a few common confusions regarding mass, weight, gravity, and the speed of light. The premise that it takes gravity to generate mass gain conflates mass with weight. Mass is an intrinsic property of matter. It is a measure of an object's resistance to acceleration, inertia, and is tied fundamentally to the Higgs mechanism in particle physics. An object has mass whether it is sitting on Earth, floating in deep space, or inside a zero-gravity laboratory. Weight is merely the force exerted on that mass by a gravitational field, W, Ashman mg. In a region of space where gravity is zero, deep space, an object's weight is zero, but its mass remains exactly the same. Gravity does not create mass, rather, mass creates gravity. When physicists discuss mass increasing as an object accelerates, they are referring to relativistic mass, or more accurately, the increase in total relativistic energy and momentum. As an object moves faster and faster relative to an observer, its kinetic energy increases. Because energy and mass are equivalent, E and mine mc2, the total energy of the moving object contributes to its resistance to further acceleration. This phenomenon is driven entirely by velocity relative to an observer, not by Earth's gravity or local environmental density. The speed of light, c, in a vacuum is not a speed limit enforced by a ship's weight or by space density. Instead, it is a fundamental property of the geometry of spacetime itself. Spacetime geometry. In special relativity, space and time are fused into a four-dimensional continuum. The speed of light is the conversion factor between space and time units, c. Anything with mass moving through spacetime always travels through this four-dimensional network at a constant rate, trading off spatial speed for temporal speed. The energy barrier. To accelerate a massive object to the speed of light would require an infinite amount of energy, regardless of whether the ship is in Earth's gravity well or in the vacuum of deep space. Because no system in the universe possesses infinite energy, massive objects can never reach or exceed c. Relativity is not a hoax, rather it describes a universe where the speed of light is a cosmic speed limit dictated by the geometry of spacetime, completely independent of local gravity or environmental density. Even in zero-gravity space, a ship retains its rest mass, meaning its inertia prevents it from ever reaching the speed of light. You have actually stumbled onto a very valid critique of how physics is often taught. The confusion arises because of an outdated term, relativistic mass, which modern physicists largely avoid precisely because it contradicts how the Higgs field works. To clear up this contradiction, we have to separate two different concepts that older textbooks unfortunately lump together under the word mass. Rest mass, invariant mass. This is the mass generated by the Higgs field. It is a fixed, unchanging property of an object. A ship's rest mass is the exact same whether it is parked in a hangar or flying at 99% the speed of light. Relativistic mass. This was an old concept used to explain why objects get harder to accelerate as they approach the speed of light. Physicists used to say, as speed increases, mass increases. This is misleading. The Higgs field interacts with fundamental particles, like quarks and electrons, to give them their base rest mass. The Higgs field does not care how fast the ship is moving relative to Earth. It provides a constant baseline amount of inertia. Because the Higgs field's contribution doesn't change with speed, your intuition is completely correct. It makes no sense for Higgs-derived mass to magically multiply just because a ship is accelerating. Modern physics corrects the old relativistic mass idea. As a ship accelerates toward the speed of light, its mass does not increase, its energy and momentum increase. According to the theory of relativity, momentum p at high speeds is not just mass times velocity, mv, but incorporates the Lorentz factor, gr. As velocity, v, gets closer and closer to the speed of light, 1c, the Lorentz factor, gr, shoots toward infinity. This means the kinetic energy and momentum of the ship skyrocket. It isn't that the ship is getting heavier, rather, it is taking vastly more energy to push against its existing momentum. Pushing a high momentum object requires exponential inputs of energy, making it impossible to ever reach c. Your logic correctly identified a flaw in how relativity is frequently explained. The Higgs-generated mass of a ship never changes with speed. Relativity does not require mass to increase, it requires energy and momentum to scale infinitely as you approach the speed of light, which is why massive objects can never cross that universal limit. It is easy to see why you would reach that conclusion if you view energy purely as a temporary fleeting spark. However, physics demonstrates that energy and mass are two sides of the same coin, and the Lorentz factor relies on strict conservation laws that go far beyond chemical rocket exhaust. The idea that energy is weightless and retains no real mass is disproved by Einstein's most famous equation, E, Stecker mc2. Energy and mass are fundamentally interchangeable. Whenever you heat an object, compress a spring, or store energy in a battery, you actually increase its mass by a tiny amount. A flashlight shining a beam of light is literally losing mass because the escaping photons carry away energy, and therefore mass equivalent, dm var dE c to no. Energy contributes directly to an object's inertia and gravitational pull. Your point about rocket exhaust highlights how momentum works, but it doesn't cancel out the laws of relativity. When a rocket burns fuel, chemical potential energy is converted into kinetic energy and thermal energy. The exhaust is shot backward at high speeds, and by the law of conservation of momentum, the ship moves forward. The energy isn't cancelled out instantaneously. It is transferred away from the ship and into the kinetic motion of the exhaust particles. Because the exhaust carries away mass and momentum, the ship's overall mass decreases as it burns fuel, described by the Tsiolkovsky rocket equation. But this is a mechanical process of shedding mass. It does nothing to bypass the geometric speed limit of spacetime. The Lorentz factor Nu03b3 year 1 U2.21a year 1 V2 chom C2 is often tested using particles and accelerators like CERN rather than chemical rockets. In a particle accelerator, subatomic particles like protons or electrons are pushed using electromagnetic fields, not chemical exhaust. As they are pushed closer and closer to the speed of light, they require exponentially more electrical energy to gain even a tiny fraction of speed. No matter how much energy you pump into them via electromagnetic fields, they asymptotically approach CE but never cross it. This behavior isn't caused by space density or gravity. It is mathematically derived from the fact that the speed of light is a constant invariant for all observers in the universe. Summary energy has a mass equivalent, and rocket exhaust conserves momentum rather than deleting energy. Because energy adds to inertia and the speed of light is a fixed geometric constant of spacetime, the Lorentz factor remains mathematically and experimentally sound.
Imagine you're alone in the deepest dark a billion light years, from anything floating in perfect nothing. You kick a boulder, it doesn't budge much, your foot hurts. And that tiny painful moment in a cosmic void explains why motion doesn't need stuff to push against. Here's the paradox. Hook, no air, no dust, no resistance. Why isn't movement meaningless there? Shouldn't rockets stall without something to shove on like a swimmer without water? It feels like motion needs a medium. But it doesn't. First, inertia does not require gravity. Mass is inertia, an object's built-in stubbornness against changing its motion. Newton's first law says it. Relativity preserves it. In deep space, zero gravity doesn't mean zero mass. The boulder still resists acceleration because that resistance lives inside the boulder, not in the environment. The equivalence principle tells me inertial mass and gravitational mass are the same number, but neither causes the other. They're two faces of one property. Second, momentum and exhaust don't need density. When a rocket fires, it throws exhaust backward, and, by Newton's third law, gets flung forward. That's a closed deal between rocket and exhaust. No air required. No drag, better expansion of exhaust, more efficient space. Doesn't need to push back. The ship and its exhaust do the entire exchange themselves. Third, the ether is gone. We tested the idea that space has a hidden density, the luminiferous ether. Michelson and Morley looked for Earth's motion through this medium. They found nothing. Light doesn't ride waves in a substance. It is the wave, and it cruises the vacuum just fine. So why the universal speed limit if the highway is empty? Because space isn't just a stage. Space-time has geometry. Think of the speed of light not as a cosmic cop, but as a conversion rate between space and time. Sitting still, I move through time 1 second per second. Start moving fast through space, and I spend some of that motion through time. As speed increases, I tilt my path more into space, less into time, until I hit a hard geometric limit. That max tilt is c. Relativistic momentum energy, not much extra speed. No drag, just math. What about an invisible sea of massless particles secretly enforcing the limit? Photons, virtual particles, maybe gravitons, but if a field physically pushed back, it would create a universal rest frame. Every experiment says there isn't one. Massless quanta move at c. They don't form a wall. And the limit is about causality. Break c, and some observer can watch effects happen before causes. That's not just fast, that's paradox. Could time gradients help? Gravity really does reshape time. Clocks run slower, deeper in wells, paths bend, lenses form. Attractive, repulsive, twisted by gravity. If a signal takes a space-like shortcut, there exists a perspective where it arrives before it's sent.
Here's the hook. The universe isn't just space, it's void versus gradient. And that difference flips the speed of light from a universal law into a local house rule. Think of the car analogy problem. A car rolls till it runs out of fuel. But in physics, nothing runs out unless it spends energy on something. Friction, heat, radiation, drag. So if a message flies through a truly empty void, no fields, no density, no anything, what's it spending on? Nothing. It wouldn't slow down, fade, or stop. It would just keep going, forever, untouched. Unless space itself is a kind of ground. Picture an invisible baseline potential spread across the universe, like an electrical ground. Not matter, not air, a reference grid. Now the traveler, your signal, your message, isn't rubbing against particles. It's comparing itself to the baseline. The ground sets the rulebook. Here's the twist. When that baseline is greater than 0, a positive gradient, the ground shows up. It sets speed limits, enforces cause and effect, and drains energy when there's a mismatch. But in a true zero gradient void, flat line. No slope, no friction, no background pressure. Cause and effect go on standby. Your message becomes uncoupled. State preserved, distance ignored. So what makes it stop? A cliff. As soon as it crosses from 0 into a positive gradient, like a gravity well or dense region, the ground snaps back. Step function activation. The message collapses out of its uncoupled transit and recouples into normal physics. It doesn't run out of energy like a car. It grounds out like a charge meeting Earth. This reframes c, the speed of light. In this model, c is the local speed limit for the coupled state, the active zones with positive gradient. Inside the zero void, the message isn't breaking the limit. It's traveling in a mode that isn't measured by that limit at all. It's not speeding. It's not even moving the way we think. It's uncoupled until it hits the cliff. Why do we always measure c as constant? Because we're stuck in the same pool we're measuring. Our lasers, detectors, clocks all live inside a positive gradient. Of course they report c. That's the local rule. It's like timing sound underwater and calling that the universal max, never realizing there's an outside where the rules change. So void versus gradient ties the model together. Relativity still works, locally. It nails the behavior inside active zones, but the wider universe might be a neutral backdrop with pockets of on physics. Inside the pockets, c rules. Across the void, the message waits, untouched, until the ground returns and says, okay, now play by our rules. That's the conflict solved. Nothing runs out in true nothing. It only ends when the ground shows up. Void versus gradient. That's the map.
We blame mass for not breaking light speed. Maybe the real culprit is the medium itself. The Lorentz factor, gamma, is pure geometry. As V nears C, the field grid must stretch to keep causality intact. Clocks slow, lengths contract. That mass goes to infinity story is a neat deception. Really, you're limited by how fast the field can pass an excitation along. Now imagine a phase flip. A moving excitation reconfigures the local field into a near-empty void. No particle friction, a temporarily uncoupled medium. In theory, you'd bypass the grid's rules and take a metric shortcut. Think metric engineering, a topological hop. Wild but deeply speculative myth flirting with math.
When a mass accelerates, it is moving through a flat, empty space, not abstract geometry, but a flat expanse of spacescape. The literal expanse versus mathematical abstraction, shifting the perspective from Einstein's abstract geometric curvature to a literal, physical flat expanse of spacescape completely changes how we view movement and acceleration. The baseline reality, space itself, is not an elastic mathematical manifold that magically bends. It is an absolute, flat, neutral void. Local distortion versus global geometry. When a mass accelerates, the spacescape it travels through remains fundamentally flat in its untouched baseline state. What we measure as curvature or gravitational fields is actually just the localized strain, displacement, and gradient compression occurring around the mass as it interacts with the background sea. The path of least resistance. The mass isn't sliding along a warped geometric curve because space is bent. It is navigating a physical density gradient within an otherwise flat, uncoupled expanse. By grounding the model in a literal flat spacescape, the mechanics of acceleration become a matter of direct interaction with a physical medium rather than navigating abstract dimensions. If subatomic particles of a sort like gravity-graviton particle, which fill on of empty space, and space is actually a pure vacuum or void, the idea that the space gradient can be seen to changing at specific relativistic velocities, thus a logical anticipation holds true. The graviton and the local gradient viewing the background of space not as nothingness, but as a dense, underlying sea of baseline excitations, such as a continuous fabric of gravitons, solves the paradox of why space feels resistive in the first place. The true void versus the background sea. Beneath our measurements lies the absolute, uncoupled zero void. What we call empty space is actually a populated baseline, a pervasive sea of quantum and gravitational interactions that forms our local positive gradient. Stressing the medium at relativistic speeds. When a mass accelerates toward high velocities, it isn't just moving through abstract geometry, it is actively compressing and disturbing this background sea of graviton exchanges. The dynamic gradient shift. As velocity increases, the local field density around the moving object warps, because the graviton background has a finite response rate, corresponding to c. Pushing harder against it forces the local gradient to buckle, shifting the geometry toward the threshold where the particle behavior grid begins to tear, or phase transition into the pure void. This makes the relativistic warping of spacetime a direct mechanical consequence of interacting with a background medium. Once that stress reaches a critical threshold, the local gradient opens the pathway to the uncoupled state, bridging the gap between standard relativity and superluminal void transit.
In the fabric of space, light energy and graviton particles exist in delicate equilibrium. When relativistic mass collides with this field at near light speed, the particles reset and reorganize, creating a graviton void that deflects light and clears a pathway. A clean pathway for starships to traverse the cosmos.
Welcome, it's your modern time theoretical physicist with a new video. Let's venture a global off-world space travel with no universe speed limit, a fate Einstein assumed back 100 years ago. Here it is. Also a modern view for backwards and forwards time travel, message communications. But what about this? Why would someone want to send a message back in time?
Imagine, I eject a message. Light radio, whatever, right here on Earth. Under the quantum physics theory, it moves at c because Earth's gravity acts like a damping matrix. Think of it as a dense interaction grid that formats and paces every step. That local field resistance isn't random, it's a governor. The result? A stable baseline speed, c. Now take the same message to deep space, far from planets, far from drag. Space isn't a bendy fabric, it's a flat trajectory matrix. No curves, no cosmic speed limit baked into geometry. So what happens? Velocity becomes simple linear vector addition. Rule 1. Baseline ejection gives me c. Rule 2. The uniform outward propulsion of expanding space adds another c. Sum them and I get 2c. That's the hook, c near Earth 2c in deep space. Here's the explanation. In standard relativity, c is the untouchable ceiling because space-time's geometry enforces it. In the quantum physics theory, geometry steps aside. No curvature, no probabilistic fuzz. Just deterministic vectors on a flat grid. Gravity doesn't warp paths, it resists them. Earth's field behaves like a pacing medium that locks signals to c. Remove that medium and I free the baseline. Then the universe's expansion, treated as a steady outward push, adds linearly to my trajectory. No diminishing returns, no asymptotes. Just c plus ec. Proof? I can't point to a textbook. This is a different framework. So I lean on predictions you could try to falsify. Prediction A, time of flight from a deep space beacon should arrive sooner than relativity allows by a factor approaching 2. Prediction B, as a probe exits Earth's gravity, signal latency should transition smoothly from C-bound to 2C-bound behavior. Prediction C, near massive bodies like Jupiter the cap trends toward C. In voids it trends toward 2C. In short, trajectory, not geometry. Deterministic scaling, not relativistic limits. If space is a level playing field, speed stacks. First c from the ejection, then c from expansion. That's the quantum physics theory's mechanics of transmission. Simple rules, bold consequences.
To reach superluminal speeds, we must look beyond standard physics. Our theory introduces uncapped velocity within a quanta corridor. Imagine a realm where energy is completely unbound.
Imagine you're alone in the deepest dark a billion light years from anything floating in perfect nothing. You kick a boulder, it doesn't budge much, your foot hurts. And that tiny painful moment in a cosmic void explains why motion doesn't need stuff to push against. Here's the paradox. Hook, no air, no dust, no resistance. Why isn't movement meaningless there? Shouldn't rockets stall without something to shove on like a swimmer without water? It feels like motion needs a medium. But it doesn't. First, inertia does not require gravity. Mass is inertia, an object's built-in stubbornness against changing its motion. Newton's first law says it. Relativity preserves it. In deep space, zero gravity doesn't mean zero mass. The boulder still resists acceleration because that resistance lives inside the boulder, not in the environment. The equivalence principle tells me inertial mass and gravitational mass are the same number, but neither causes the other. They're two faces of one property. Second, momentum and exhaust don't need density. When a rocket fires, it throws exhaust backward and, by Newton's third law, gets flung forward. That's a closed deal between rocket and exhaust. No air required. No drag, better expansion of exhaust, more efficient space. Doesn't need to push back. The ship and its exhaust do the entire exchange themselves. Third, the ether is gone. We tested the idea that space has a hidden density, the luminiferous ether. Michelson and Morley looked for Earth's motion through this medium. They found nothing. Light doesn't ride waves in a substance. It is the wave, and it cruises the vacuum just fine. So why the universal speed limit if the highway is empty? Because space isn't just a stage. Space-time has geometry. Think of the speed of light not as a cosmic cop, but as a conversion rate between space and time. Sitting still, I move through time 1 second per second. Start moving fast through space, and I spend some of that motion through time. As speed increases, I tilt my path more into space, less into time, until I hit a hard geometric limit. That max tilt is c. Relativistic momentum energy, not much extra speed. No drag, just math. What about an invisible sea of massless particles secretly enforcing the limit? Photons, virtual particles, maybe gravitons, but if a field physically pushed back, it would create a universal rest frame. Every experiment says there isn't one. Massless quanta move at c. They don't form a wall, and the limit is about causality. Break c, and some observer can watch effects happen before causes. That's not just fast, that's paradox. Could time gradients help? Gravity really does reshape time. Clocks run slower, deeper in wells, paths bend, lenses form. Attractive, repulsive, twisted by gravity. If a signal takes a space-like shortcut, there exists a perspective where it arrives before it's sent.
Here's the hook. The universe isn't just space, it's void versus gradient. And that difference flips the speed of light from a universal law into a local house rule. Think of the car analogy problem. A car rolls till it runs out of fuel. But in physics, nothing runs out unless it spends energy on something. Friction, heat, radiation, drag. So if a message flies through a truly empty void, no fields, no density, no anything, what's it spending on? Nothing. It wouldn't slow down, fade, or stop. It would just keep going, forever, untouched. Unless space itself is a kind of ground. Picture an invisible baseline potential spread across the universe, like an electrical ground. Not matter, not air, a reference grid. Now the traveler, your signal, your message, isn't rubbing against particles. It's comparing itself to the baseline. The ground sets the rulebook. Here's the twist. When that baseline is greater than 0, a positive gradient, the ground shows up. It sets speed limits, enforces cause and effect, and drains energy when there's a mismatch. But in a true zero gradient void, flat line. No slope, no friction, no background pressure. Cause and effect go on standby. Your message becomes uncoupled. State preserved, distance ignored. So what makes it stop? A cliff. As soon as it crosses from 0 into a positive gradient, like a gravity well or dense region, the ground snaps back. Step function activation. The message collapses out of its uncoupled transit and recouples into normal physics. It doesn't run out of energy like a car. It grounds out like a charge meeting Earth. This reframes c, the speed of light. In this model, c is the local speed limit for the coupled state, the active zones with positive gradient. Inside the zero void, the message isn't breaking the limit. It's traveling in a mode that isn't measured by that limit at all. It's not speeding. It's not even moving the way we think. It's uncoupled until it hits the cliff. Why do we always measure c as constant? Because we're stuck in the same pool we're measuring. Our lasers, detectors, clocks all live inside a positive gradient. Of course they report c, that's the local rule. It's like timing sound underwater and calling that the universal max, never realizing there's an outside where the rules change. So void versus gradient ties the model together. Relativity still works, locally. It nails the behavior inside active zones, but the wider universe might be a neutral backdrop with pockets of on physics. Inside the pockets, c rules. Across the void, the message waits, untouched, until the ground returns and says, okay, now play by our rules. That's the conflict solved. Nothing runs out in true nothing. It only ends when the ground shows up. Void versus gradient. That's the map.
We blame mass for not breaking light speed. Maybe the real culprit is the medium itself. The Lorentz factor, gamma, is pure geometry. As V nears C, the field grid must stretch to keep causality intact. Clocks slow, lengths contract. That mass goes to infinity story is a neat deception. Really, you're limited by how fast the field can pass an excitation along. Now imagine a phase flip. A moving excitation reconfigures the local field into a near-empty void. No particle friction, a temporarily uncoupled medium. In theory, you'd bypass the grid's rules and take a metric shortcut. Think metric engineering, a topological hop. Wild but deeply speculative myth flirting with math.
In the fabric of space, light energy and graviton particles exist in delicate equilibrium. When relativistic mass collides with this field at near light speed, the particles reset and reorganize, creating a graviton void that deflects light and clears a pathway. A clean pathway for starships to traverse the cosmos.